humanity's farthest messenger, a lone probe hurtling through the dark for nearly half a century, has reached the very edge of our solar system. Out there, it was supposed to find silence, a vast, cold emptiness. Instead, it found something that defies our scientific models. More than 25 billion kilometers from home, at the boundary of interstellar space, Voyager 1 has made an impossible discovery. It's sending back signals that hint the universe is far stranger and a lot less empty than we ever dreamed. So what did it find out there in the great silent dark? To really get what this discovery means, you have to know the messenger. It doesn't have a name, just a designation. Voyager 1, launched by NASA on September 5, 1977. It's a relic from a bygone era of exploration, a time capsule of human ambition built with tech that seems impossibly primitive now. The total memory of its onboard computers isn't just thousands of times weaker than the smartphone in your pocket. It's more like 1,000,000 times weaker. And its data? It's recorded on a digital tape recorder that, while mission critical, is conceptually a cousin to the 8-track tapes of the 70s. Yet this humble machine, weighing less than a small car, has become humanity's greatest explorer. It was born from a dream called the Grand Tour, a once-in-a-176-year alignment of the outer planets that would let a single craft visit Jupiter, Saturn, Uranus, and Neptune. 2 probes were built, Voyager 2, which launched first, and Voyager 1, which followed 16 days later on a faster track. Now, they weren't our first eyes on the gas giants. The Pioneer 10 and 11 probes had already made flybys. But the Voyagers gave us our first truly breathtaking, high-resolution look, revealing worlds more dynamic and violent than we had ever conceived. Voyager 1 discovered the first active volcanoes beyond Earth on Jupiter's moon Io, found faint new rings around Jupiter, and unveiled complex ring structures at Saturn. But its main mission ended in 1980, after buzzing Saturn and its mysterious moon Titan. While its twin, Voyager 2, journeyed on to Uranus and Neptune, Voyager 1's path flung it up and out of the plane of the solar system, onto a new, lonely trajectory. Its mission changed. It was no longer a planetary explorer. It had become a messenger to the stars, its destination, the infinite void. For over 4 decades, it's been traveling in darkness. It moves at a staggering 17 kilometers per second, a speed so immense that a bullet fired alongside it would seem to be standing still. Every day, it puts another 1.4 million kilometers between itself and home. Sometime around November 2026, it's projected to be so far away that its radio signals, traveling at the speed of light, will take a full 24 hours to reach us. It will be 1 light day from home. It is the most distant object ever made by human hands, a silent emissary from a world it will never see again. Before it ventured into the great unknown, Voyager 1 performed one last poignant task. In 1990, at the request of the legendary astronomer Carl Sagan, NASA turned the probe's cameras around for a final family portrait. From 6 billion kilometers away, Earth appeared as a tiny speck of light, a mote of dust suspended in a sunbeam. This was the pale blue dot, an image that forever changed our perspective. As Sagan so eloquently put it, look again at that dot. That's here. That's home. That's us. With that final humbling glance, Voyager 1's cameras were powered down forever to save precious energy for the long trip ahead. Its mission now was to listen, to taste, to feel the environment as it sailed toward an invisible boundary no one had ever crossed. For years, then decades, it flew through the solar system's outer suburbs. The sun shrank from a blazing star to just the brightest star in a sea of others. The journey was long and quiet. The probe's instruments measured the fading breath of the solar wind, the stream of charged particles flowing from our sun. But everyone knew it was heading for a frontier, a place where that solar wind finally gives way to the interstellar medium, the thin gas and dust drifting between the stars. What would that frontier be like? Scientists had theories, elegant equations, and complex simulations. They expected to find a clear edge, but the universe rarely does what we expect. As Voyager 1 got closer to this unseen shoreline, the data it sent back started to get weird. The models began to break. The first surprise came as it neared a region called the termination shock, where the solar wind was supposed to slow down abruptly. It did, but not how anyone predicted. At times, the wind even seemed to flow backward toward the sun. The magnetic field, which was expected to be a certain way, was also all over the place. It was the first clue that the edge of our solar system wasn't a simple wall, but a chaotic, messy, and incredible place. To understand what Voyager 1 found, you have to picture our solar system as a bubble. This bubble is called the heliosphere, and it's inflated by the solar wind. Think of our sun as a ship sailing through the galaxy. The heliosphere is its bow wave, pushing aside the interstellar ocean. The outer edge of this bubble, where the sun's influence ends and interstellar space begins, is called the heliopause. That's the true shoreline of our solar system. For decades, scientists argued about where this shoreline was. Early estimates were all over the map. Voyager proved them all wrong. It passed Jupiter, Saturn, Uranus, and Neptune, and the heliosphere just kept going. The models were constantly being updated. No one knew for sure when Voyager would finally break through. Then in 2012, something changed. On August 25th, at a distance of about 18 billion kilometers from the Sun, Voyager 1's instruments saw a sudden dramatic shift. The flood of particles from our Sun dropped to almost zero, while cosmic rays, particles from deep space, spiked like crazy. It was as if the probe had sailed out of a calm harbor and into a raging open sea. But there was a catch. One of Voyager's key instruments, designed to directly measure the plasma density, had failed way back in 1980. Without that direct measurement, some scientists were hesitant to pop the champagne. They needed a smoking gun. They needed to know the density of this new environment. Interstellar space was predicted to be way denser than the inside of our little bubble, and then the universe gave them a gift. A huge solar eruption back in March 2012 sent a shock wave hurtling through space. More than a year later, in April 2013, that wave of energy finally washed over Voyager 1. The blast made the plasma around the probe vibrate to ring like a bell. Another instrument, the plasma wave subsystem, heard that ring, and from its frequency, scientists calculated the density. The result was undeniable. The plasma was about 40 times denser than anything it had measured before, a perfect match for what they expected to find in interstellar space. After a 35-year journey, Voyager 1 had officially crossed the shoreline. It was the first thing made by humans to ever enter the space between the stars. Reaching interstellar space was a monumental achievement, but the mission was far from over. For the first time, humanity had a direct probe in this new, unexplored territory. And this is where things got really weird. After the excitement of the 2013 solar event, scientists settled in to listen. The assumption was that the interstellar medium would be pretty quiet. They figured Voyager's plasma wave instrument would only pick up those ringing plasma oscillations when a shock wave from one of our sun's storms passed by. In between those events, they expected silence. They were wrong. As researchers sifted through the data, a new, completely unexpected signal started to show up around 2017. It was very faint, but it was persistent. It wasn't a sudden burst from a shockwave. It was a low, steady hum. Imagine being in a perfectly silent, empty room, and then you start hearing a low, constant tone from no apparent source. That's the kind of paradigm-shifting moment the Voyager team was having. The interstellar medium, the very fabric of space between the stars, was humming. According to the models, this was impossible. The plasma out there shouldn't just be singing on its own. It was supposed to be a passive medium, only getting excited when something like a solar shock wave hit it. But Voyager's data was clear. Even with no solar events, the plasma was oscillating, generating a faint but constant signal. The signal is more of a whisper than a shout, but the fact that it's continuous is what has stunned scientists. It suggests the space between stars isn't a quiet, placid void. It has its own background noise that we never knew was there. What's causing it? The team has ideas, things like thermally excited plasma oscillations or quasi-thermal noise, but the honest answer is they don't know for sure. Voyager 1 has stumbled upon a fundamental property of our galactic neighborhood that was completely missing from our theories. It has revealed that the emptiness of space is, in fact, alive with a faint, ceaseless vibration. This faint hum from the darkness challenges everything we thought we knew. The scientists who have dedicated their lives to this mission are still trying to figure out what it all means. Before we dive into the implications of this impossible signal, take a moment to subscribe. We're dedicated to bringing you the most awe-inspiring stories from the final frontier, and you won't want to miss what comes next. So, what does this impossible hum mean? It may not be a message from ET, but its scientific importance is off the charts. It's given us a revolutionary new tool to explore the cosmos. The hum is essentially the sound of space itself. By listening to its pitch, scientists can do something they've never been able to do before: continuously measure the density of the interstellar medium. Before this, our measurements were just snapshots. We could only get a reading when a solar shock wave happened to pass by, which is only about once a year. But the hum changes everything. It provides a steady stream of data, letting scientists map the density of space with incredible detail as Voyager travels. And what that map is showing is just as surprising as the hum itself. The interstellar medium isn't smooth and uniform. The density fluctuates, revealing a turbulent, dynamic environment. The hum rises and falls in pitch, showing that Voyager is passing through cosmic clouds and voids of plasma. It's like discovering an ocean we thought was perfectly still is actually filled with powerful currents, eddies, and weather systems. This has huge implications for understanding our own cosmic bubble, the heliosphere. The structure of the interstellar medium directly affects the shape and behavior of our home. It's the environment our solar system is flying through, and its turbulence likely buffets and squeezes our protective shield in ways we're only just beginning to understand. This is crucial for figuring out how well that shield protects us from dangerous galactic cosmic rays. Voyager's discovery isn't just a fun fact, it's fundamental data about the very environment that shapes our place in the galaxy. The discovery of this hum does more than just tweak our physics models. It speaks to a deeper truth about exploration. Every single time we push the boundaries, we find our assumptions were too simple. We expect emptiness, and we find complexity. We expect silence, and we find a symphony. This is a powerful lesson in scientific humility. For all our advanced theories, the universe is not obligated to follow our script. It is consistently stranger, more intricate, and more active than we imagine. The fact that a spacecraft built in the 1970s, with technology nearly 50 years old, can still completely upend our understanding of the cosmos is a testament to how much we still have to learn. What other assumptions have we made that are just plain wrong? What other subtle signals are we missing? The hum from interstellar space is a reminder that we've only just dipped our toes into the cosmic ocean. Voyager 1's data suggests this ocean isn't a featureless void, but a place of immense structure and energy. It forces us to reimagine the space between the stars not as an empty stage, but as an active character in the cosmic drama. The story of Voyager 1 is the story of humanity's reach exceeding its grasp. It has survived glitches, dwindling power, and the unimaginable cold and radiation of deep space. Its nuclear power source is fading. To save what little energy is left, NASA engineers have been forced to make heartbreaking choices, shutting down its systems one by one. Soon, its science mission will end. Then, it will fall silent forever. And yet, even in its twilight, it continues to rewrite our textbooks. This discovery of a persistent hum in the void is a stunning final act in a mission full of them. This lone wanderer, now over 25 billion kilometers away, has shown us that the void is not empty. It has a voice. Voyager 1 will continue its journey in silence, a ghost ship sailing through the interstellar